Implementing fault tolerance mechanisms. Implementing fault tolerance mechanisms is crucial to ensure the reliability and resiliency of microservices at the edge. In this tutorial, we will explore various strategies and techniques for building fault-tolerant microservices that can withstand failures and ensure continuous availability. Circuit breaker pattern. This section introduces the circuit breaker pattern, a vital technique for managing remote service failures in microservices. It allows applications to handle faults gracefully and maintain reliability. The circuit breaker pattern is a popular technique for handling remote service failures. It is implemented by wrapping calls to remote services in a circuit breaker object that monitors the service's response. When the service fails repeatedly, the circuit breaker trips and subsequent requests are short-circuited, preventing further requests from being sent. This pattern helps in isolating faults, reducing cascading failures, and provides the application with the ability to handle failures gracefully. Isolating faults is essential to prevent cascading failures throughout the system. The circuit breaker pattern helps in managing this by stopping further requests to a failing service, thus maintaining overall system stability. 2. Retry and backoff mechanisms. Retrying failed requests can improve fault tolerance by allowing the system to recover from transient failures. Implementing a retry mechanism involves retrying failed requests with an exponential backoff strategy. In this strategy, the system waits for an increasing amount of time between retries, reducing the load on the failing service and increasing the chances of recovery. Retry and backoff mechanisms improve fault tolerance by increasing the chances of successful requests, ensuring that transient failures do not significantly disrupt service availability. Graceful degradation. When a microservice depends on another service that is experiencing issues, it can implement graceful degradation mechanisms to continue operating with limited functionality. Based in the identification of critical features and non-critical features, the microservice can degrade gracefully by disabling non-critical functionalities and providing partial services to users. This ensures that even during service disruptions, the microservice can still be partially operational. Failover mechanisms. Implementing failover mechanisms is essential for providing high availability and fault tolerance. Failover involves redirecting requests from a failed service to a backup or secondary service. This can be achieved by using load balancers or service discovery mechanisms to automatically route requests to an alternative healthy service. Additionally, adopting an active-passive failover approach ensures that the backup service takes over seamlessly when the primary service fails. Scalability and load balancing. Scaling microservices horizontally by adding more instances helps in handling increased loads and improving fault tolerance. Load balancing distributes incoming requests across multiple instances, ensuring that no single instance is overwhelmed. This not only improves fault tolerance but also enhances performance and responsiveness by utilizing the available resources efficiently. 6. Graceful shutdown and state management. During a planned shutdown or system maintenance, it is essential to gracefully handle the termination of microservices. Graceful shutdown ensures that the microservice completes any ongoing requests, closes open connections, and maintains states when shutting down. Proper state management is crucial to avoid data corruption or loss during shutdown and ensures that the microservice can recover seamlessly when restarted. Graceful shutdown processes facilitate seamless recovery, allowing systems to continue functioning without significant disruptions. Resilient communication protocols. Choosing a communication protocol that supports fault tolerance and resilience is essential for ensuring reliable microservice interactions. Implementing protocols like HTTP with retry policies, connection pooling, timeouts, and circuit breakers can help handle unreliable network conditions, transient failures, and service disruptions effectively. Implementing fault tolerance mechanisms is critical for ensuring the reliability and resiliency of microservices at the edge. Techniques such as the circuit breaker pattern, retry and back-off mechanisms, graceful degradation, failover mechanisms, scalability and load balancing, graceful shutdown, and resilient communication protocols enable microservices to continue operating despite failures and provide a seamless user experience. Based on these strategies, developers can build robust and fault-tolerant microservices architecture that can withstand various failure scenarios.